dangers of electricity. What is electricity? A form of energy consequential from the existence of charged particles, such as electrons or protons, either statically or as a current. Where does electricity come from? Electricity comes from many sources, such as coal power plants, nuclear power plants, and renewable energy sources such as wind, solar, and hydroelectric dams. These resources generally are combined into regional electric companies, which sell you the power they generate for a monthly bill, which you pay, so that the plant can buy more of its fuel source to make more power for you or maintain the machinery. What are the dangers of electricity and their causes? Indirect dangers. The storage and use of electricity is often associated with sparks, electrical or electrostatic discharges. For example, motors with brushes have short arcs between the brush tips and the moving rotor constantly during operation. Relays and switches open and close with a small arc between the contacts. Plugging in an appliance which is already turned on causes a small spark. Connecting a battery to a device which is turned on will also cause a small spark. And finally, there is the common release of static electricity that occurs when a charged body comes into contact or near contact with a body at a different potential. If the atmosphere in which the spark occurs is loaded with sufficient particulates, or a flammable gas, one spark can set off an explosion and/or a fire. Another indirect danger associated with electricity, and directly connected with the above danger of explosions, is the danger of fire. Not all explosions ignited by an electric spark result in a subsequent fire, but many do. So, even if a person survives the initial blast, unless they are removed from the area, they could be injured or killed by a subsequent fire. A final indirect danger associated with electricity is associated with one of the physiological responses of the human body to an electric shock, and is the hazard of being involuntarily moved by the electric shock. The body's muscles contract when they receive a small electrical signal from the brain through the nerve system. External electrical signals, such as those resulting from an electric shock, can also cause muscle contraction, as demonstrated in 1791 by Luigi Galvani and his experiments with frogs and electricity. These externally caused muscle contractions are involuntary, and in many cases can be violent. Direct dangers. The direct dangers associated with electricity are primarily divided into burns and cardiac effects. The former danger can readily be modeled when considering the body as a conductor of electricity. The later danger is much more complex, and involves an understanding of the normal operation of the heart and the interfering action electricity can have on it. Burns. The flow of current through a resistive material is always associated with the production of heat. The primary resistive material of the human body is the epidermis, the layer of dead skin cells that lies on top of the dermis. This layer of skin is relatively dry, and the cells themselves are also dry, having died and released their moisture. Thus, this layer of skin provides a reasonable amount of resistance to the flow of electricity. Once electricity enters the body through the skin, it encounters very little resistance due to the electrolytes, conductive fluids, contained within the body. Therefore, the skin is where the greatest heating occurs, since the heat is proportional to the resistance. Cardiac effects. 1 milliampere will cease the human a sensation, 2 milliamperes will give the human a mild shock, 10 milliamperes will cease the human from being able to let go, 20 milliamperes will contract the human's muscles, 30 milliamperes will cause the human to suffocate, 100 milliamperes and the human's heart will stop, 300 milliamperes and the human will stop breathing, 900 milliamperes and the human will suffer from severe burns. And at 1000 milliamperes is when a 100-watt bulb will be lit. The danger is that these electrical currents will interrupt the normal electrical signals of the body that cause the rhythmic contractions of the heart muscle. When this happens, the heart enters a state of fibrillation, which is essentially the ineffective random quivering contractions of the heart, rather than the rhythmic full contractions that pump blood. How can the dangers of electricity be prevented? Only work around electricity when you are trained in all aspects of the job when you have a reason to be there. When working around a power line, get the utility company to mark all the dangerous areas. Cover all electrical outlets with plug socket guards. They are cheap and easily obtainable. Where an appliance has a plug that pushed into the rear of it, such as with portable stereos etc., make sure that the child cannot pull the plug out. If they do and put it into their mouth, it could be very serious. If you're not qualified, then don't mess with electricity. It is not visible, so you don't know if it's there without special equipment. If in doubt, call for a qualified electrician. Advantages of these solutions. Society. It keeps the society safe and healthy as they are not exposed to electricity and electrical wires during their daily lives. Economy. It helps the economy grow, because less people are endangered by the electrical wires and outlets, so they are able to benefit as more people will need healthy to work and let the economy grow. Environment. It helps the environment look cleaner because there weren't dangerous wires everywhere, and it also makes it safer. Disadvantages of these solutions. Society. If a fault occurs in an area out of ready reach, it may cause a dangerous fire that will result in many deaths. Economy. Money will need to be put into buying safety items, such as insulators and wire covers. Environment. If we put signs in areas and have boards everywhere, it will interfere with the scenery.